Good morning. Welcome to today's session. So I don't want to make it longer. So I'm just gonna quickly explain the most important things you should know in this distribution. In the previous lectures, we looked at the first three probability distributions, which are discrete probability distribution, binomial probability distribution, and the Poisson probability distribution. So I told you clearly that it's very important for you, ladies and gentlemen, to know all the properties of these discrete, of these probability distributions. My apology. So today we are going to look at normal distribution of probability. So it is the most simplest of them all. So it just needs you to come up with a fresh mind so that you can pay special attention to what I'm going to say. So I want to present my screen here so that you can see what I'm explaining. So be informed that in this lecture, I'm not going to make use of the graphs to explain the normal distribution. But then in most cases, before we start with our lecture, before we actually start with this lesson, with this distribution, I normally ask the students whether they are normal or not. So if you say, yes, I am normal, then you should have reasons why you are saying you are normal, meaning that there are certain things we can see in you that make you to be normal or that make you to be abnormal, I mean to say. So even in this chapter, we are going to look at such. Why are we saying this curve is normal? So when we look at the normal distribution curve, we are saying it's normal because it is bell-shaped. So its shape looks like a bell. And then secondly, it has a property of being symmetric. By symmetric, we are trying to say the left-hand side of the curve, which is given by 0.5, the area here is 0.5, is the same as the right-hand side, which is 0.5. So when you add this 0.5 with 0.5, you will get 1. Therefore, they make this curve to be symmetric, meaning that, I'm sorry about that, meaning that this portion here, the left-hand side, should be similar to the right-hand side, this area here. So in that case, we will say our curve is normal because it already has two properties. The first property is bell-shaped. The second one, it is symmetric. I don't know what's happening. Yeah, but then when we say this is symmetric, remember in the other chapters, we said mean is equal to mode equals to median. And then this makes our curve to be symmetric. So that is just a little bit of introduction about this chapter, right? So we are now gonna look at the formulae. As I have said, I won't be making use of the graphs to calculate the probabilities. So I will be making use of the formulae because I have realized that majority of the students do not understand the graphs. So I won't make use of the graphs, but I want to make you understand something with these graphs first before I introduce you to my formula. So remember, this is a graph, the normal curve, and then a 0, which is the origin is here. So if you find that your probability is this side, So it's on the right-hand side of 0, the right-hand side of your origin. It means that it is positive, or we can say it is greater than 0, meaning that it is positive, right? So we say it is one-sided. Greater than 0 means one-sided, and one-sided means on the right-hand side of the curve. So you can say it is one-sided, and you further say it is upper-tailed. So this is the upper tail. But then if it's less than 0, it means that it's still one-sided and it's on the left-hand side here. So on your left-hand side, so it's less than 0, right? Your 0 is here, less than 0 means this side. And therefore, we are talking about this left-hand side, right? So that is negative. It means that we will say is lower tailed, right? So we have upper tail and lower tail. Make sure you understand those. We will still need that information when we do what we call a hypothesis testing. So we are now going to look at the formulae. As I have said, I won't make use of the graphs because they confuse a lot of students. Rather, we are going to make use of this formulae. It's very important for you to know all of them so that you don't go wrong in the test or in the quiz or in the exam. So if you master this formula, then there's no way you can go wrong. Are we together? So the first formula I want to introduce to you is this one, number 1. So if remember, when we deal with normal distribution, we are also, when it comes to all these probability distributions, I told you in the previous lessons that we are going to calculate the mean, we are going to calculate the median, we are going, I mean to say not the median, we are going to calculate the mean, we are going to calculate the variance, we are going to calculate the standard deviation, we are also going to calculate the probabilities, right? So before I actually come to the formula, let's start here. Let's start by calculating mean. So when we calculate mean of a normal distribution, it will be given by E of what? E of X, depending on what you are given, right? So if you are given the X value, it means that we will say the expected value of X equals mu, and then you will always be given mu from the statement. Don't forget this. So they will say calculate the mean while they have already given you the mean, meaning that you are supposed to write this formula and then you write the answer you are given on the question. I mean, say from the statement, then that will be your mean. You have calculated it. So it's the first formula for calculating mean. But then when we are given the standard, the X bar, so we will say expected value of X bar, which is the same as the expected value of sample mean, is the mean of the sample mean. Remember, expected number is the same as mean. Mean is the same as average. So this E here denotes expected number or mean or average. Therefore, when we pronounce this, we will say it is the expected number of sample mean or mean of the sample mean, which can also be written as mean of the sample mean. And then you know it's equal to population mean. And then you will always be given the population mean from the statement. So you just substitute it here, you get the answer. So they will give you mean on the statement. They further say calculate mean of the sample mean. So mean of the sample mean is given by this or this, and then it's equal to this. So the reason mean of the sample mean is equal to population mean is that it is an unbiased estimator of the population parameter. So mean of the sample mean is equal to the population mean because it is an unbiased population parameter or the unbiased estimator of the population parameter. I hope that is clear. Don't forget. So the other thing you need to know when it comes to this probability distribution normal, so you need to know how to calculate the standard error or standard deviation of the sample mean. Remember, standard error is the same as standard deviation. So in the test, you might be asked to calculate standard error of the sample mean. So you must know that they are one and the same thing. So we say this is standard error because it's standard deviation, and then your subscript, you will say of the, and then you know X bar is sample mean. So meaning that this one is standard error of the sample mean equals, so this is the formula for calculating standard error of the sample mean. So on your statement, you'll be given sigma, you'll also be given the value of n. So you just take those values, you substitute them here, and then you will get your standard error of the sample mean. That is very important. So if they say calculate the variance of the sample mean, meaning that they need sigma squared variance of the sample mean, meaning you can just square both sides here, right? You square both sides, and then at the end you will have sigma divided by the square root of n squared. So you will have sigma squared because this exponent here multiplies with the exponent here, which is 1. Then you'll get 2 times 1 because of this bracket. And then you will get 2 divided by 2 multiplied by the exponent here, which is also 1. So you will get, when you remove this square root, you will have n to the power 1 over 2, right? Which is multiplied by that 2. So 2 times 1 over 2, you will get 1. So at the end, you will get this over n as the formula for calculating this. I hope it makes sense to you. So for now, I think that is all. So let's look at the other things. So if you are given the value of X, right, you will need to standardize it to the value of Z. If when we standardize, we are transforming. So we are changing the value of X to be the value of Z. And I will show you how to change it from the value of X to the value of Z. So if you are also given the value of X bar, you still transform it, or you standardize it, or you change it to the value of Z. Very important as well. So when we transform the value of X to get the value of Z, we will say Z equals that value of X minus the mu divided by standard deviation. So you need to know this one is very important. This one and this one, you get them from the statement. And then this one, always the one that is before this sign, you must always memorize this. Whatever you see before this negative sign will be given from the question or on the question. So I hope it makes sense. That is just a formula for transforming the value of X to get the value of Z. So when we transform X bar to get Z, the formula will be slightly different from that one of transforming x to get z. So we are transforming x bar, remember. So we'll have x bar minus your mu divided by standard error or standard deviation of the sample mean. You see the difference between transforming the value of z and the value of x bar. So the difference is here. When you transform the value of x bar to get the value of z, the difference will be here and also here. Whereas when it comes to x, the difference is here and here. So that is very important. Don't confuse the two. And you know the formula for calculating this. So this one, the formula you know, or we can rearrange this equation to get x bar minus mu, and then we simplify this part here. Then we will have sigma over square root of n. So this is the formula for calculating standard error of the sample mean, which is this part here. You can also confirm. Hello.
Hello, Stephen. How are you?
I'm good, thanks. And how are you, ma'am?
I'm good. I see
Yes.
your email that there are mentors that
My apology about that. I had to quickly respond to the call. It was important, so there was no way I can ignore it. So, and I was also kicked out of the session. Yes, this is where we were. I was saying the formula for calculating standard error of the sample mean was here. This one, right? It was the formula for calculating standard error of the sample mean. That is the formula for calculating standard error of the sample mean. And I taught you, I have already explained, right? So that is why I'm saying we can rearrange the equation to this. So we are now going to look at the other things. I have already explained the issue of standardization. I hope by now you understand. So now, what is important again is for you to know this. The formulae, as I have said, we'll be making use of the formulae instead to calculate the probabilities when it comes to normal distribution instead of those tables. I mean, say those graphs. So number one, formula number one, probability of Z. Remember, there's no way you can calculate, take note of this. There's no way you can calculate the probability without having the value of Z. When it comes to normal distribution, there is no way you can calculate the probability without knowing the value of Z. Very important. So if you ever find yourself working around a normal distribution and you are saying you are calculating probability, whereas you are not having the value of Z, just know that your answers are wrong and they will forever be wrong and you will fail. So probability of Z greater than A. A can be any value, might be 0. Okay, I'm sorry, let's continue. As I was explaining, why is my screen not visible? As I was explaining, if the probability of Z is greater than A, and I said A can be any value, might be 1.2, 1.7, 2.9, 100.12, any value can be represented by that value, that A, right? So it will be equal to, remember we are calculating probability, right? So an assumption is that, remember I told you that greater than A, meaning that is the same as greater than 0. So if it's greater than 0, it is one-sided, right? And it is upper-tailed because of greater than. And if we go back to our graph, if we go back to this graph, one-sided, remember I told you that each side has an area of 0.5, right? And we said that one is one-sided because it's greater than 0 and is lower-tailed. So we will have 0.5 here because it is one-sided. Make sure you understand. So because of this sign greater than here, if something is more, for example, if you have more sugar level in your body, it has to be reduced. So meaning that because of this greater than, we are going to subtract, and then probability of whatever you have here, probability of A. So if your probability of A is, if your A is 1.67, you will say probability of 1.67. I hope it's clear. So if it's not clear, you can go back to the recording and play it over and over again until you understand. So the second equation, probability of Z less than A, we do the same. This is one-sided, you know, and then it is lower tail because less than 0 means that it's negative, so it's on the left-hand side. So because it's one-sided, if you go back to that graph, if we draw it here, you know each side has an area of 0.5. So meaning that we expect to see 0.5 there because it's one-sided. So we'll have 0.5 as well here. And then because it's less, because of this sign here, less, if you have a lower sugar level in your body, we are supposed to add certain things so that your sugar level goes back to normal. So meaning that if we are given the value of Z greater than any value that is positive, so we are going to say when you calculate probability 0.5 minus the probability of that Z value. And we get the probability of that Z value from our normal distribution table known as Z table. You will see it as we continue. So I hope that was clear. If it's not, you can always go back and replay. So Z is less than A. So the third equation, probability of your Z can be between the value of A and the value of B. Equals. We cannot say this one is one-sided because there are two variables, A and B. So we cannot use 0.5, right? So you are going to take this one, probability of B, you subtract the probability of the smaller one, which is probability of A. You are subtracting because they are both positive. And if they are both positive, we assume that they are more. And if they are more, we are supposed to reduce them. So we assume this probability of B, because of this sign here, we assume it's more, and then we have to reduce it by the probability of A. So I hope it makes sense. Let me write it very well here. So it's probability of Z between A and B. It will be given by probability of B minus probability of A. Then you will get the answer. Then the last two equations, you just introduce the negative. Let's say you have probability of Z greater than negative A equals. So if you know the first three equations, then automatically you know the remaining one, right? So we are saying A is now negative, right? Look at equation number 1. A is negative. So A is negative here. So this negative multiplied by this negative will give us positive. So we'll have 0.5 plus probability of A instead of minus. So because negative times negative, you get positive. So number 5, if probability of Z is less than negative A, it will be equal to, it's still one-sided, 0.5, and then you go to this one. So A is now negative, A is negative. So this negative times positive, you will get negative, and then probability of A. So it's very important for you to know those formulae. So we'll be making use of those formulae to calculate the probabilities of a normal distribution. Let me erase them and write them very well. Okay. So number 1, probability of Z greater than A equals 0.5 minus probability of A. I'm just rewriting them. Probability of Z less than A equals 0.5 plus probability of A. So 3, probability of Z between two values, which are A and B, will be given by probability of B minus probability of A. And then number 4, probability of Z score greater than negative A will be given by 0.5 plus probability of A. Number 5, probability of Z less than negative A equals 0.5 minus probability of A. So I just rewrote the formulae because I have explained how to get them earlier on. So we are going to make use of this formulae. So let's look at an example. The statement reads as follows. Given that X, which denotes the flight times between city A and city B, follows a normal distribution with a mean of 64. You have to write what you are given on the statement. We are given a mean of 64. So we are given population mean of 64. How do we know that this is population mean and not a sample mean? Listen carefully. So we are saying is a population mean because they did not mention anything about a population or a sample. If they just say this is a mean, just know it belongs to the population, provided they did not mention anything about a population or a sample. They are not specific. If they are not specific, it automatically belongs to me, to population, I mean to say. Same applies to the standard deviation that we are given here. It is for population, which is 2.5. The reason we are saying it's for population is because they did not mention anything about the population or a sample. In other words, they are not specific. So if they are not specific, an assumption is that they both belong to the population. Clear? So we are continuing. So now remember, we have two situations or two scenarios when it comes to normal distribution. Sometimes we will be working with the X value. We standardize the value of X to get the value of Z. Sometimes we standardize the value of X bar to get the value of Z. So how do you know that now I am standardizing the value of X instead of the value of X bar? Or how do you know that now you are standardizing the value of X bar instead of the value of X? And this is an answer to that question. The answer is you read your statement thoroughly. You also look at your question. Remember, I said on your question, you'll always be given either X or X bar. So if you are given X on your question, it means that you are standardizing X to Z. But if you are given X bar, it means that you are standardizing X bar, and you know the formulae for standardizing those. So now we are calculating probability of X greater than 67.4. So you can look at the equation and then you will see the one you are going to use. But you can only tell the correct equation after you have calculated the value of Z. Without the value of Z, you cannot tell the equation. So I hope that is clear. I'm trying to get myself a calculator here, but I can't find it. So you will just calculate. Okay, it's here. We are transforming it, right? We are transforming it to the value of Z. So it will be probability of Z instead of X greater than, then the formula for transforming X to Z is what? Is X minus your mu divided by your sigma, which is equals to probability of z greater than your x. I said you get it from the question, and then you go back to the question. So your x is 67.4. So it's question A. So your x is 67.4. So it's greater than 67.4 minus your mu. I said it will be given on the statement. So you are given mu of 64, and then sigma is also given as 2.5. So you substitute them. 64 divided by 2.5, and then you close the bracket. So you will have probability of z, and then you calculate that z value. So you will have 67.4 minus 64, you divide by 2.5, and then you get the answer. So I got my answer as 1.36. Now from here, you can tell the formula we are going to use. So our value of A is now given as 1.36. Which formula are we going to use? So we need probability of Z greater than A. Our A is 1.36 equals. You go to the formula sheet, this one. Which formula are we going to use? Number 1, number 2, number 3, number 4, or number 5? The correct formula, yes, is number 1, because the value of Z is greater than positive A. So meaning that we are going to use 0.5. Look at formula number 1. We are going to use 0.5 minus probability of the value we got. So meaning that we will have 0.5 minus probability of our A, which is 1.36. And then you can simplify your things further here. Minus. Remember, 1.36 is not probability. 1.36 is the value of Z. And I told you that there's no way you can calculate probability in normal distribution without getting the value of Z. So you go to the Z table now. Where is my Z table? It's here. So this is our Z table. And then we need 1.36, the probability of 1.36. And then you start with the first two numbers here, 1.3, and then you locate 1.3 on these values. So can you see 1.3? It's here. It's your 1.3. And then you remain with what? With 1 has already been used, it's no longer there, comma, 3 is no longer there, so you remain with 0 as well, and then 6. Therefore, the remaining 6, you are going to check it on top here. The values on top. So your 0.06 is here, and then you check where 0.06 and 1.3 intersect. That is the probability of what? The probability of 1.36. And the probability of 1.36 in this case, can you see it? Is 0.4131. So meaning that you can substitute now. So you have your value of probability of 1.36 is 0.4131. And then you punch this on your calculator. 0.5 minus 0.4136. 0.5 minus 0.4131. The answer is 0.09. So I hope you understand, right? So meaning that those formulae are very important. So instead of using the graphs that are very confusing, you can make use of this formulae. So let's look at the second question. It says we calculate probability of X between 65 and 67.4. So we are going to calculate as well. Is probability of X, they said, is between 65 and 67.4. But let me confirm. Here is 65 and 67.4. So you can also look at the formula sheet. You will see the formula you are going to use. But before that, you are supposed to get the value of Z. You can only tell the correct formula after transforming this X. We are not using the X as it is. We have to transform it to the value of Z. So meaning that we will say probability of Z between, we transform the first X value, which is 65. So it will be 65 minus your 64 divided by sigma, which is 2.5. The same formula we were using before. And then this side will do the same, 67.4 minus your 64, you divide by 2.5. And then you'll get probability of 65 minus 64 divided by 2.5. The answer is 0.40. So you have 0.40 here. And then Z, this. And then this side we have already calculated it. We got 1.36. Now from here you can tell the formula you are going to use. So Z is between a positive value of A and a positive value of B. So which formula are we going to use? So we go back to the formula sheet, which is here. So the formula we are going to use is this one, because the value of A is positive and the value of B is positive. So we'll say probability of B, the value you see here, you subtract the probability of the value here. So you will have the probability of 1.36. This is your B. You subtract the probability of 0.40 equals. We have already obtained the probability of 1.36 from the table. We got 0.4131. Then we are going to subtract the probability of 0.40. 0.40 is not the probability, it is the value of Z. So you go to the Z table. You go to the Z table, and then we want to find the probability of 0.40. Probability of 0.40. So I said you start with the first two values. So you locate them here. So 0.4 is here, right? And then the remaining value is 0. And then you check the last value here, which is 0. So where these two intersect, you will get the probability. They intersect at 0.1554, meaning that the probability of 0.4 is 0.1554. So you can substitute it here, 0.1554. And then you just punch your calculator, you will get your answer. So the answer is 0.26. Always check your answer. The final answer should always be between, remember, the universal property of probability is that probability of a certain value of X or a certain value of Z will lie between 0 and 1 both inclusive. So your answers should never exceed or go beyond this interval, which is the universal property of the probabilities. I hope we are together up to so far. So we are going to look at another question, which is this one here. They are saying, suppose a random sample of N, which is 25 observations, is selected. So you are supposed to collect your data when you deal with this kind of questions. So you are given the value of N. You are given the value of N as 25. And then from a normally distributed population with a mean of 106. So this is your population mean. They told you that it's a population. So the mean of 106. And then the standard deviation is also given as what? As 12. Therefore, they want you to calculate mean. They gave you mean, but they want you to calculate mean of the sample mean. So you still remember the formula. Mean of the sample mean is given by mean of the sample mean, which is equal to your mean. So you have your mu here, which is 106. You just substitute it here, 106. Then you will get a mark there. So remember, we said this is because the mean of the sample mean is an unbiased population. I mean to say is an unbiased parameter of the an unbiased estimator of the population parameter, I mean to say. So we have calculated the first question. The second one, they are saying you must also calculate standard deviation of the sample mean. So how do we denote standard deviation of the sample mean? The standard deviation of the sample mean. And the formula is, you know it, I told you before. Sigma over the square root of n. And you are given all this. Your sigma is given as 12 divided by the square root of the n is 25. And then you calculate, you will get your answer. So your answer is 2.40. So you have responded to those questions. And then we now go to another question, another example. So we are almost done. No, I don't want this one. I actually need, where's that question? It's not here, but then let me take a picture. So this is the question. This is our question, right? So let's read. Given a normal distribution with a population mean of 100, population mean of 100, population mean of 100. So how do we denote the population mean? We are given a population mean. We are given a population mean of 100, which is mu. What else? And a standard deviation of 12. Standard deviation of 12. If you select a sample of 36, that is a random sample. So n equals 36. And then what is the probability that the sample mean? Very important. the probability that the sample mean is above 102, meaning that the sample mean is above means greater than 102. So now you can see that we are given X bar. It means that we are standardizing the value of X bar instead of X, because from the question we are given X bar. So this will be given by the probability of Z. We are transforming X bar to Z greater than, and then remember the formula we said is X bar, which is 102 minus mu, you are given mu as 100 over standard error of the sample mean, which is given by sigma over the square root of n. Sigma is 12 over the square root of your n is 36. You can always refer to the equations I gave you before. So we will have something like this, and then it will be probability of Z greater than, let's calculate 102 minus 100, we divide by 12 over the square root of 36. And then the answer is 1. Right? So that is the same as 1.00. So which formula are we going to use? You go back to the formula sheet, you will see that A is positive and is greater than 0. So we are going to use the first formula. So meaning that we will have probability of Z greater than 1 equals 0.5 minus the probability of 1. And then you follow the same procedure, 0.5 minus, you go back to the Z table, you find the probability of 1. We need the probability of 1. So we need 1.00. So you locate 1.0 this side. So this will be your 1.0, right? And then 1.0, and then you check 0 on top here. The one that ends with a 0, this one. So you check where they intersect. And then you'll see the probability is this one, which is 0.3. I can't see clearly. Let me try something here. Yeah, is the probability of 0.3413. So meaning that probability of 1 is 0.3143. I hope you got it right. Probability of 1 is the same as 0.3143. And then you can substitute it here. 0.3143. And then you will calculate. The answer will be between 0 and 1, both inclusive, because it's probability. So I got 0.09. And then you can go to the second question, which says between 95 and 97.5. This one is still the same as the one we did before. So between 95, it's between 95 and 97.5. Probability of your X bar between 95 and 97.5. So you transform or you standardize those values of X to Z. So you will have probability of, where you see x bar, you are now going to put z because we are transforming it. And then it's 95 minus your mean is what? Your population mean is 100 over your what? Your x bar, I mean to say your sigma is what? Is 12 over the square root of the n is 20. Is it 25 or 36? It's 36. So your n is 36. And then this side you will have 97.3. You subtract population mean, which is 100. You divide by the sigma, which is 12, divided by the square root of n, which is 36. And then you do your calculation. So you will get probability of z between negative 2.5 and negative 1.5. This is what we have. It's probability of z between negative 2.5 and negative 1.5. Remember the property of a normal distribution, we said it's what? We said it's symmetric, meaning that if we have negative 1.5 here and then negative 2.5 here, and then this side we have 1.5, this side we have 2.5. Remember, we don't have a Z table for negatives in our lesson. The table is there if you check with other sources, such as the internet. So you will get the Z table with negative values. But in Atlas, we don't have. So we always rely on the ones of positive, right? So what I'm trying to say here is that the distance traveled from the origin to this, and then from this to this, is the same as the distance traveled from 0 to this, and then to this. Meaning that the probability of negative 1.5 is given by probability of 1.5, and then of 2.5 is given by 2.5. So when you calculate the probability here, you will take the bigger probability. So this is equal to probability of the biggest value, which is 2.5. You subtract the probability of the smaller one, which is 1.5. And then you go to the table, the Z table. We need 1.5 and 2.5. Let's start with 1.5, which is the same as 1.50. You locate 1.5 here, and then your 1.5 is here, and then 0 at the end. You must check the value here that ends with a 0, and then it will be this one. This one ends with a 0, this one ends with a 1, this one with a 2, and so forth. So you take the one that ends with a 0 because you have remained with 0 here, and then it means that it's 1.5 and 0.00. So the probability will be this one here, 0.4332. And then now we need the probability of 2.5, which is the same as 2.50. So you do the same. 2.5, you check it here. The 2.5 is here. And then you remain with 0. You remain with 0. Then you check the one that ends with a 0 here, which is this one. So it will be 2.5 and this one, and then the value is here, 0.4938. So meaning that we have 0.4938 probability of 2.5 is 0.4938. You subtract probability of 1.5, what did we get? We got 0.4332. 0.4332. And then you subtract them. So it's so I'm sorry about that. The connection is unstable this side. So you know how we arrived here, right? So you just punch your calculator. So we got these values from the table. So 2.5, negative 2.5, we took the 1.4, positive 2.5, and then same applies to this one. And then I even used what? I used a graph to show you how we arrived at this. Again, why we were saying we are supposed to subtract. So you just punch your calculator, you will get a value that is between 0 and 1, both inclusive. 0.4938 minus 0.4332. You will get 0.06. Then that is your answer. So what else do we need to do? The last one for proportion, this one. In a sample of 64, so the value of n is 64. 48 are classified as successful. Don't you ever dare say that is the probability of a success, because you will fail. Remember, I said probability can never be greater than 1. So that is the value of x, because it is what we get from the sample of those 64 people. So in that sample of 64 people, 48 of them are classified as successful. So it is the value of x. And you know the formula for calculating proportion is given by x over n. So you can calculate your proportion before you go any further. It's 48 over 64. And then the answer is 48 over 64. The answer is 0.75. So if the population proportion is 0.8, remember we denote population proportion by pi. And then we will say we are given P as 0.75. We have calculated it. The value of n is 68. Was it 68 or 64? It's 64. 64. And then we are given population mean, which is what? 0.8. Determine the mean of the proportion and standard error of the proportion. So they want us to calculate mean of the proportion, which is given by mean of the proportion equals population proportion, and then your population proportion is 0.8. That is a formula. It's the same as the one for mean. Expected mean of X bar, and then you substitute X bar here, and then here we had mean, and then you substitute your mean here. But then now we are dealing with proportion. You substitute proportion inside the bracket, proportion as a subscript, and then proportion here, population proportion instead of population mean. So they also want us to calculate standard error of the sample proportion, which is given by the square root of pi into 1 minus pi divided by n. You know this formula I showed you before. So your pi is 0.8. You multiply by 1 minus your 0.8 is pi, and then divided by the square root of n. Your n is 64. And then you will get the answer. That is what they are looking for. Standard error of the sample proportion. So if they say calculate the probability of, let's say, they want you to calculate probability of P greater than 0.6. It's an example, right? Meaning that you need to standardize the value of P. So we'll have P of, how do we standardize it? So when we transform P to Z, we will get Z equals your sample proportion, you subtract your population proportion, you divide by the square root of pi into 1 minus pi, you divide by the value of n. And this part is the same as standard error of the sample proportion. So let's transform it. Probability of P greater than 0.6. When it's standardized, we will have the probability of Z greater than your sample proportion is what I said, the one you see before that negative sign is always given on this question, which is 0.6 minus, you have your population mean, which is 0.8. You divide by the square root of your pi is what? Is 0.8. Then 1 minus 0.8, you divide by the value of n is 64. And then you punch your calculator. You get probability of Z greater than, let me calculate, the answer is going to be negative by looking at that equation because the upper part is negative. 0.6 minus 0.8, we divide by the square root of 0.8 into 1 minus 0.8, close bracket, the value of n is 64. So the answer is -4, -4.00. So now A is negative, right? It's the same as probability of Z greater than -A. So you know the formula. And then we will have 0.5 plus 0, I mean to say the probability of that A. You can always refer back to the formula sheet, the one I gave you. So meaning that we have probability of Z greater than -4.00 equals 0.5 plus the probability of 4 equals 0.5 plus, you go to the Z table. You go to the Z table. Unfortunately, the one I have posted here does not have a 4. But if it had a 4, you will go to that 4, right? So you go to that 4 and then you check 4. Mind you, we need 4.00. So 4.00 is the same as 4.0. You locate 4.0 this side. If it was here, you go to 4.0 and then you look at these ones on top here. Yeah, network is giving us problems. Okay. And then you check 0, you check the value that ends with a 0 here, and then you check where they intersect, you take that probability and then you will substitute it. You are going to substitute it here. Then you add the 2, you will get a value that is between 0 and 1, both inclusive. So that will be your answer. So I think we are done with normal distribution. Yeah, wishing you all the best in your upcoming quiz. Make sure you ask me the questions whenever you need clarity on something, right? I'm always available on WhatsApp. You can even call if needs be, and then I'll be able to assist. So thank you very much. Our session will end here. Bye.